Alright students, today we are going to solve a very beautiful problem, and the problem says n identical balls are placed at rest on a frictionless horizontal surface. The first ball is projected with speed u towards the second ball. After collision, the second ball moves and hits the third one, third hits the fourth, and so on, and this continues all the way up to the nth ball. The coefficient of restitution for every collision is E. We need to find the speed acquired by the nth ball. So let us begin. Now we comes on the solution of this problem. This is a chain collision problem, and the motion is transferring from one ball to the next, like this: 1 to 2, 2 to 3, 3 to 4, and all the way to n. Here all balls are identical, all are at rest except the first one. And the same coefficient of restitution E applies at every single collision. Now our job is simply to find the speed of the last ball. Let us start with the very first collision, that is ball 1 hits ball 2. Before collision, ball 1 has speed u and ball 2 is at rest. After collision, let ball 1 have speed v1 and ball 2 have speed v2. Here, since all masses are equal, so let each mass be m. Now we write two equations. The first one is based on the principle of conservation of momentum. Here mu is equal to mv1 plus mv2, that is u is equal to v1 plus v2. This is our first equation. Now we use the definition of coefficient of restitution for our second equation. By definition, E is equal to relative speed of separation upon relative speed of approach. That is, E is equal to v2 minus v1 upon u minus 0, and in this way we get our second equation, that is v2 minus v1 is equal to EU. Now we solve these two equations simultaneously, and after adding these two equations together we get 2v2 is equal to u plus E into u, that is 2v2 is equal to u into 1 plus E, and v2 is equal to u times 1 plus E upon 2. This is the speed which is transferred to ball 2, and here we get a key idea, and the idea is every time an identical moving ball collides with an identical stationary ball, the stationary ball receives a speed which is exactly 1 plus E upon 2 times the speed of the incoming ball. Now this factor 1 plus E upon 2 is going to play an important role in our forthcoming steps of solution. Now ball 2 moves forward and collides with ball 3. Here ball 3 is at rest. The situation is exactly the same as before, that is identical masses, same coefficient of restitution E. So applying the same logic, we get v3 is equal to 1 plus E upon 2 times v2, and after substituting the value of v2 we get v3 is equal to 1 plus E upon 2 times u into 1 plus E upon 2, that is v3 is equal to u times the square of 1 plus E upon 2. For ball 4, applying the same logic, that is v4 is equal to 1 plus E upon 2 times v3, and after substituting the value of v3 we get v4 is equal to u times cube of 1 plus E upon 2. So here the pattern is clear, and based on it we get a general formula for kth ball, that is vk is equal to u times 1 plus E upon 2 to the power k minus 1, and because to reach the kth ball there are k minus 1 collision, so the power of k minus 1 is very logical. Now we simply put k equal to n and we get Vn is equal to u times 1 plus e upon 2 to the power n minus 1. That is Vn is equal to u into 1 plus e to the power n minus 1 upon 2 to the power n minus 1. And this is our final answer. Now let us understand what this answer is actually telling us physically. This factor 1 plus e upon 2 controls how much speed gets transmitted at each collision. If e is equal to 1, that is perfectly elastic collision, the factor becomes 1. So Vn is equal to u and the last ball gets full speed. So no energy is lost anywhere. But if e is less than 1, the factor is less than 1. So every collision reduces the speed slightly and the final ball receives a progressively smaller speed. And our final case in which if E is equal to 0, that is perfectly in elastic collision. Here each collision transfers only half the speed. So Vn is equal to u times 1 upon 2 to the power n minus 1. So students, the beauty of this problem is that one single key observation, that every collision multiplies the speed by the factor 1 plus e upon 2, and this is enough to solve the entire chain. And this is the power of recognizing patterns in physics. Thank you.